Hello everyone, my name is Nana.
My name is Josh.
And my name is Mitch, and this is Project 4 Design and Manufacturing Strategies and Processes.
Over the past semester in ME 3210 with Dr. Hassan Rashidi, we have discussed and researched a variety of advances, innovations, and trends in design and manufacturing. Today we will discuss 10 of these topics that we found the most interesting. We will talk about what they are, their capabilities and limitations, their significance, and a couple real-world examples. The topics discussed today will play a big role in the future of design and manufacturing, so we hope you're excited to learn. Without further ado, let's begin.
To highlight why these innovations and trends in manufacturing and design are key, let's first look at the effect of manufacturing on the country's economy. The manufacturing sector is the fourth largest GDP contributor to the country, and last year, about $2.3 trillion was contributed, which is about a tenth of the total GDP. 17.1% of the total GDP also comes from direct and indirect value added by manufacturing. This high production rate makes the US the world's second largest manufacturer, and about $1.6 trillion of goods was exported last year. These goods range from cars such as Tesla to petroleum and pharmaceutical products. The booming sector attracts foreign direct investment as well, and about $2.2 trillion was invested last year. The competitive nature of the industry pushes companies to be more innovative, and in fact, manufacturers perform 52.9% of all private sector R&D. Manufacturing is the backbone of the US economy, and this is why the topics to be discussed are important. Advancements in manufacturing are advancements in the country's economic development, and it supports innovation, economic stability, and regional development. There are some environmental concerns and energy consumption concerns, but overall, it's a benefit. Now let's talk about product benchmarking. This is an R&D process that involves comparing one's products and features to those of competitors to improve competitive position. It allows companies to clearly see their strengths and weaknesses and make data-backed decisions. There are various metrics and key performance indicators that can be used whilst benchmarking, and these include user retention and survey scores, and it varies from product to product. The example image shown compares survey scores for various aspects of two products. We clearly see that product B does better in service while greatly lacking in design. During my summer internship with a tech startup, I got to do some benchmarking of my own. The team was building a wearable device capable of playing music by voice commands and wanted to know the hierarchy of needs for their feature set. They didn't have enough people to implement everything immediately, and so I did some research into the various music platforms and observed how devices interacted with those platforms by voice. I then was able to determine the order in which to implement features, and this helped us to move quickly. Benchmarking is important because it guides decision making in things such as material selection, functionality, and cost effectiveness. It also allows manufacturers to identify strengths and weaknesses of their product relative to competitors and provide actionable data for product improvement. It is, however, time consuming and depends on the availability and recency of competitor data. Now let's talk about MVP, minimum viable product. This is the simplest version of a product that meets core functionality requirements and can be tested with users. It shows the proof of concept and explains capabilities and is useful for providing feedback for future development. The people who mainly use these are early customers. As you see in this photo, there's an MVP for movement, starting from a skateboard and ending at a car, and an MVP for a light product, starting from a candle and ending at a ball. Amazon is a leading example of MVP's potential success. Jeff Bezos started it as a simple online bookstore in the 90s, and now it sells every single thing you can think of. It focuses on functionality first, and then prioritizes reliability, usability, and eventually brilliant design, which it is known for today. MVP is key to design because it minimizes the risks and costs associated with full-scale product development. It supports agile development, promotes iterative improvements, and engages users early. However, overly minimal designs might fail to capture user interest or meet expectations as users might not fully understand it. Retrofitting involves upgrading existing systems, machines, or products to enhance performance or functionality without complete replacements. Upgrades can be done using sensors and products and machines or additional materials and structures. So as you see here, it can be done in construction with steel brace reinforcement or in manufacturing by replacing old interfaces with new ones. A very common and more recent example of retrofitting is CarPlay in older car models. Users want to have the capabilities of a touch screen in their older cars and to replace the old interfaces with one that is more intuitive and has GPS and music and every single thing that you would expect from a more modern car without having to buy an entirely new car. Retrofitting is a cost-effective way of bringing older systems up to date, supporting sustainability and reducing waste. It extends the lifespan of assets and reduces environmental impact. However, it can be complex and may not achieve the same performance as newer systems.
Now let's discuss generative design. This relatively new design tool utilizes artificial intelligence to produce a range of solutions to a given problem. The current market for this technology is expected to reach around $926 million by the year 2030. Currently in the market, engineers are using generative design to cut down on material costs while maintaining structural specifications, such as this bike that's been produced on the right. Two fields commonly used in generative design include topology and lightweighting. Topology analyzes how the arrangement of parts in a system impacts its ability to meet specifications, whereas lightweighting focuses on removing unnecessary material in the system. Generative design assists design engineers in producing the most effective solution, ultimately balancing quality and cost. Generative design will be very important in the future of design, as AI works alongside engineers to solve the world's most pressing problems. This design tool is capable of reducing time in the prototyping stage and cutting costs. The only downfall may be that it fails to account for human factors, such as how visually appealing a product may be. Now let's explore the concept of digital twins. Digital twins are virtual counterparts to physical systems that can run simulations and make predictions. They commonly leverage data from sensors, IoT devices, and other sources to make a dynamic model that can be interacted with. These sensors collect real-time data and alert manufacturing workers when a system may need attention. Interacting less with a physical system will also drive safety in the workplace. Finite element analysis is a key component of the concept of digital twins. FEA simulates the behavior of a physical system by gathering metrics such as pressure, tensile stress, or force, and then predicts the system's outcome. In our world today, there are digital twins of even the largest systems, such as a windmill. This technology alerts workers when maintenance is needed on the system and prevents unneeded interaction with such large machines that could be dangerous to workers. Digital twins are capable of automating lots of the quality evaluation process, increasing production flow in the manufacturing floor, and making the job safer. However, it's limited as it requires a large investment on the front end to set up these systems, and maintenance of the sensor systems themselves may be really difficult. And now let's delve deeper into how the sensors in a system may communicate to engineers. The Internet of Things, or IoT, is a system of sensors or microdevices that communicate to one another. More specifically, the industrial Internet of Things is the use of IoT in the manufacturing world to drive efficiency in the workplace. As our world moves more towards the idea of Industry 4.0, where factories are more intelligent and efficient than ever, IIoT will play a key role. The industrial Internet of Things is capable of tracking the big data in a system, which will allow manufacturing workers to focus on creativity. Unfortunately, with such a large data storage network, the technology could be susceptible to cyber attacks or other big events. One particularly interesting application of this technology is the transition of IoT into the human body and healthcare. Researchers are currently working on nano-electromechanical devices and sensors that would allow for the detection of infectious disease or life-threatening events before a patient is even aware. IIoT is currently being used in new pacemakers to transmit data like heart rhythm to a patient's doctor for monitoring.
A light cell factory is a fully automated facility that operates without human intervention, often run 24/7. These factories rely on robotics and sensors to handle tasks like assembly, machining, and quality control, enabling continuous, efficient production. Lights out factories are important because they maximize productivity, reduce labor costs, and ensure consistent quality. They help manufacturers meet high production demands while minimizing downtime and errors, making them a critical tool for staying competitive in modern industries. Light cell factories enable continuous operation, shortening production times and increasing output. They are ideal for precision manufacturing, maintaining high quality without interruptions. By automating repetitive tasks, they free workers to focus on creative and innovative aspects of product development, leading to faster and more efficient production cycles. Lights out factories offer unmatched efficiency, consistent quality, and minimal downtime, making them ideal for standardized, high-volume production. However, they require significant upfront investment, rely on precise maintenance, and are less flexible for custom tasks. Despite these challenges, they remain a powerful tool for modern manufacturing. Collaborative robots or cobots are designed to work safely alongside humans in shared workspaces. Unlike traditional industrial robots, cobots are equipped with sensors and advanced programming to ensure safe interaction. They are used for tasks like assembly, quality inspection, material handling, and packaging. Cobots are important because they combine human adaptability with robotic precision. They enhance productivity, reduce repetitive strain on workers, and improve flexibility in manufacturing, making them essential for modern, efficient production processes. Cobots take over repetitive or physically demanding tasks, allowing workers to focus on creative and complex projects. They are excellent for precision assembly, ensuring consistent quality. Cobots can also conduct real-time quality inspections, reducing defects and waste, and improve workplace safety by collaborating closely with humans. Cobots offer high precision, adaptability, and enhanced safety for human operators. They are also cost-effective and easier to deploy than traditional robots. However, they have limitations such as lower speed and payload capacity compared to industrial robots, reliance on accurate programming, and a need for worker training to integrate effectively into workflows. Augmented reality or AR overlays digital information into the real world using devices like smartphones or AR glasses. In manufacturing, it's used for tasks like assembly guidance, training, maintenance, and virtual prototyping, helping to visualize and interact with complex systems in real time. AR is crucial because it bridges digital and physical workflows, reducing errors, speeding up processes, and enhancing collaboration, all of which are essential in today's fast-paced industries. AR allows designers to validate ideas by projecting 3D models into real-world spaces, spotting issues early. It guides workers with visual assembly instructions, reduces training time, and overlays diagnostics during maintenance. AR also assembles virtual prototyping, saving time and resources by eliminating physical prototypes. This technology streamlines workflows and improves product quality. AR provides real-time visualization, enhances training, and reduces errors. However, high implementation costs, reliance on high-quality hardware, and the need for accurate data can pose challenges. Despite these limitations, AR's benefits make it a transformative tool in modern manufacturing. In this video, we've explored a range of advancements and trends shaping the future of design and manufacturing. From immersive applications of augmented reality and collaborative potential of cobots to the efficiency of lights-out factories and the connectivity of IoT and IIoT, each innovation is playing a vital role in transforming the industry. We've also looked at how tools like digital twins, generative design, and retrofitting enhance production processes, while strategies like product benchmarking and minimum viable product development ensure competitive and high-quality results. Finally, we've examined the broader impact of manufacturing on the economy, underscoring its importance beyond individual products or companies. Together, these technologies and approaches highlight how manufacturing is evolving to be smarter, faster, and more efficient while maintaining adaptability, sustainability. Understanding their capabilities and limitations is essential for leveraging them effectively, staying ahead in this rapidly changing landscape. Thank you for watching. We hope this has been an informative look into the innovations shaping the future of design and manufacturing.